Hello everyone, welcome back to Chapter 6. In all honesty, this video may not be completely necessary as it's going to be very similar to the last, the Chapter 6 Part 1 video. But there's a few points I want to make. I want to do another example a little further on in the chapter. One of the problems, one of the things that I shouldn't say problems, one of the things that Excel allows is to calculate normal distribution problems using the binomial distribution that we used earlier in the book. Because of the similarity to which they are calculated, it's actually a more accurate method of calculation when doing it over with the computer. When doing the problems by hand, you pretty much have to do the normal distribution calculation. But through the computer, we're allowed to do the binomial, and it allows for a much more accurate answer. So I'm going to go ahead and go through an example like that. We're going to do in Chapter 6, Section 6.6, Problem 18. So let's go ahead and Chapter 6, Problem 6, Section 6-6. Okay. The problem reads, in example 2, it was noted that a recent Pew Research Center survey showed that among 2,822 randomly selected adults, 2,060 or 73% stated that they are internet users. A technology specialist claims that 75% of adults use the internet, and the results from the survey showed that a lower percentage because of random chance variation in surveys. Assuming that the 75% rate is correct, is a result of 2,060 internet users an unusually low number when 2,822 adults are randomly selected. So what they're essentially asking here is how much variation due to survey error can be, how much input can survey error have on variation is probably a better way to word it. So what we have here is a study showed that 73% of people are internet users. And an expert says it's 75%, and anything different from his opinion is just due to survey error. And we're going to find out if that's true. So let's go ahead and set this up as a binomial distribution. It meets all the qualifications, and it will give us a more accurate answer to take this approach for this type of problem than the normal distribution approach. So first we're going to do the number that we've got, which was 2,060. Number of trials was 2,822. The probability is 0.75. Now the reason we're using 0.75 is we're calculating the probability of achieving these numbers, the 2,060 out of 2,822, with the expert's number of 0.75. And our result is going to tell us what are the odds of this actually happening if his 0.75 number is correct. And we're going to choose cumulative, hit return, and there's our answer. So the odds are less than 1% that we're going to get these numbers with his percentage. So in this case, we're going to assume that the expert is wrong and that the 0.73 from the research study, the 73%, was correct. All right, that does it for Chapter 6. We'll see you again for Chapter 7.